We have a representation of functions by power series, so we're going to take a function and we're going to try to represent that function using everything that we know about power series, but more specifically a geometric power series. And so we have one technique for finding a power series to represent a given function is to recognize the function as the sum of a geometric power series. Today we use that technique. Example, find a power series for f of x equals 1 over 1 minus x squared, centered at x equals 0. Find the first four non-zero terms in the general term. Also find the interval of convergence. So let's see. We start out with, we want f of x to be represented by a geometric series. So we have a over 1 minus r. We want our function to look like this function, and we're very close to having that. Because ours looks like 1 over 1 minus x squared, so the a equals 1, and the r is x squared. So our first four non-zero terms are 1, and then 1 times x squared is x squared, and then times x squared is x to the fourth, and our fourth one times x squared is x to the sixth. So this can be, if we went out to infinity, we'd have n equals 0 to infinity of, let's say, a is 1, so 1 times r to the n, and our r is x squared, and that's going to be raised to the nth power. We can simplify this a little bit since our a is n, our a is 1, we don't really need that. So we have x to the 2n. If you have a power to a power, you can multiply the powers. We're going to find the interval of convergence, which means the absolute value of our r in this case is x squared, has to be less than 1. So we have negative 1 is less than x squared is less than 1. Well, if we look at x squared is going to be less than 1 when x is actually between negative 1 and 1. Think about if x was 1/2, then we square that, we get 1/4. And if x was negative 1/2, and we square that, that's also going to be 1/4. So it doesn't really make a whole lot of sense to say that x squared has to be greater than negative 1. Of course it's going to be, but that allows us to investigate x, and we see that x, as long as x is between negative 1 and 1, x squared will also be between negative 1 and 1. In our next example, we're going to find a power series for this function, 1 over 4 minus x, with the same instructions that we saw earlier. So let's get to it here. We want g of x to look like a over 1 minus x. Now we almost have that, we just have to get this 4 to be a 1. So what we can do is divide everybody by 4. So we have 1/4 over 1 plus x over 4. And we're very close. We have the 1s where we need them, but now we just have a plus in between instead of a minus. So this is going to be 1/4 over 1 minus negative x over 4. Now a negative is going to be that plus. So now our a is 1/4, and our r for our geometric series is negative x over 4. So now we can write the first four non-zero terms. The first one is 1/4, and then we multiply by negative x over 4, so we have negative x over 16, and then plus x squared over 64, and then we finally have minus x to the third over 256, I believe. Yeah, 16. Yep, 256. So that's equal to, if we took this out to the nth term, we'd have, or the infinite term that is, we'd have n equals 0 to infinity of, our a is 1/4. Remember, this is a geometric series. R is negative x over 4 to the nth power, and there's no way to simplify this. Now we're asked to find the interval of convergence, so the absolute value of our r, which is negative x over 4, has to be less than 1. So we can write negative 1 is less than negative x over 4 is less than 1. Multiply everybody by 4. Actually, if we multiply everybody by negative 4, we get 4 is greater than x is greater than negative 4, but we could turn that around and say negative 4 is less than x is less than 4. So our interval of convergence is negative 4 to 4. In our third and final example, we are going to find a power series for h of x equals 12 over 2x minus 1. But look, we are centered not at x equals 0 anymore, but we're centered at x equals 2. So this is going to be a little different. But very similar steps, actually. We want h of x to equal a over 1 minus r. So we have to, well, let's take this negative 1. Let's put it out in front. So we have 12 over negative 1 plus 2x. And remember, now we're centered at x equals 2, so we're going to put x minus 2 in for x. So we have x minus 2, but look what we've done. We've changed the denominator into negative 1 plus 2x minus 4, which is negative 5 plus 2x, and that's not what we want. We want to keep it as negative 1 plus 2x. So to remedy that, we're going to add 4, which would add 4 here, which would make that 0 and keep it as negative 1 plus 2x. So now this is equal to 12 over 4 plus negative 1 gives us 3 plus 2 times x minus 2. Remember, we have x minus 2 here because this thing is centered not at 0 but at 2. Now we have to divide everybody by 3 because we want this number to be 1 to have it in the proper form. So now we have 4. Oh, remember, we're dividing by 3. 12 divided by 3 is 4. 1 plus 2/3 x minus 2. Now we almost have the form that we want, except we want a minus, and this right now is a plus. So we finally have 4 over 1 minus negative 2/3 times x minus 2. And our a is 4, and our r is negative 2/3 times x minus 2. Well, we could find our first 4 non-zero terms. The first term is 4, and then we have minus 8/3 times x minus 2, and then plus 16/9 times x minus 2 squared, and minus 32 over 27 times x minus 2 to the third. And we can take that out to infinity, and we're not going to write that much. We're not going to write to infinity. I don't want to be here that long. We're going to write n equals 0 to infinity of a, which is 4, times the r, negative 2/3, times x minus 2 to the nth power. And we want to finally find the interval of convergence. So we have negative 1 is less than negative 2/3 times x minus 2. And now I just have to get x by itself. So we're going to multiply by negative 3/2. That'll turn the signs around and make these numbers opposite. So it ends up being negative 3/2 is less than x minus 2 is less than 3/2. And then we add 2, which is 4/2. So we end with 1/2 less than x is less than 7/2. So the interval of convergence is 1/2 to 7/2. So this is a good approximation of the original function as long as x is between 1/2 and 7/2.